Hi everyone, today we're going to finish up 1.4. So the last thing I want to talk to you about is this concept. So for some of you who have taken physics or taking physics right now, you might notice or might find this familiar. The last things I want to talk to you about is the concept called components. So what does mean by component? So basically is this. So let's say we're given a vector x. What we can do is the following. We can create two components of vector x such that the following things are true. And when we define these two components of x, I do need to define something about it. So we want to create two components of x in the direction of the unit vector u. That's satisfied. So these two components will satisfy the following condition. So what are these conditions? So number one, and I'll show you a picture to kind of illustrate what that means. Number one, these two components, one of the components is in the direction of vector u. And number two, one component, the remaining components, is perpendicular to the direction u. And number three, the special thing about these two components is the sum of these two components is basically vector x. So basically what I want is to kind of separate this vector x into two pieces, where one go in the direction of a given direction u and one go in the perpendicular direction. So what does that mean is this. It basically means the following. So I'll show you a picture. Suppose I have this vector, which is vector x. Then what I want to do is to break this vector x apart into two components. One of them go in the direction of u. So this is in the direction of u. And then the other one is perpendicular to the direction u. And what does this look like? Well, if you're thinking about what you learn in physics, then you probably make the connection here. So one of them is usually referred to as the horizontal component, and the other one is usually referred to as the vertical component, meaning that you probably remember learning in physics about projectile motion. When you shoot something at an angle, you can break the motion of that object into a horizontal component and a vertical component, or the x direction component and a y direction component. For us, not only we can do horizontal and vertical, we can actually do any direction that we want as long as we specify it in vector u. So how does it work? So I'll show you that first of all, the component that's in the direction of u, we often refer to that as the projection. The reason why I call it projection is because you can imagine that this component is like the shadow of the vector x when the light shines directly from the top. So that's what happened in this picture. If the light go from the top of the page, go straight down, this arrow right on the bottom would become like the shadow of x. That's what we call projection. Now, since the projection must be in the direction of u, therefore indicate that it must be a multiple, a scalar multiple of u. Why? Well, because if I do a scalar multiple of u, I can keep the direction, which is what I mean, in the same direction as u, but just have different length. And why do I need that? Because the vector u is a unit vector. So I only have a length 1, and there's no guarantee that vector x would have just so happen the right length, so that its shadow is length 1. So I'm going to have to modify its length to do that. So how do I do that? I'm going to go and write this down first. The projection is often referred to as vector p, and that will equal to some scalar multiple of vector u. And we're going to have to figure out what that scalar multiple is. Now, I'm going to go ahead and say this. The letter p, vector p, can be referred to some other things in later section. Okay, so make sure you understand in what context are we using this. So in here, when we talk about projection, vector p is the component which is called a projection, which is in the direction of u. So what happened to the component that's perpendicular? Well, this one doesn't have a specific name. We call it vector q. And what's the deal with vector q? It means that vector q dot product with p or dot product with u must equal to 0 because they're perpendicular. And then what happened to the last one? The last one simply say that if I add p and q together, I should get x. So in this scenario right here, what you'll be given is x and u, and what you go try to do is to find out p and q. That's basically what the problem is. So in these type of question, most likely you will be given vector x and vector u, and you need to find vector p and vector q. So the question is, how are we going to do that? So actually, it's actually pretty simple. So show you how that is done. Okay, show how it's done. So if I look at this picture right here, or actually maybe I draw a new picture. How's that? We'll draw a new picture. So let's say here's my vector x, which is given to us. And I'm going to go ahead and say this is my vector u, which is a unit vector. And now what I'm going to try to do is try to figure out these two vectors. So one of them is this one, which is vector p, which is the projection. And then this one, which is vector q, which is the perpendicular vector. So how we actually go about doing this? So remember, we do know x and u, and therefore indicate that I know the length of x and the length of u. In order for me to find the projection vector p, notice that we already know the directions of p, because p has to be in the direction of u, so therefore it has to be the same direction as u, but just simply have to be longer, or it could be shorter actually, but have to be a different length. So all I really have to do is just kind of figure out how long it needs to be. And the way to do that is actually pretty simple. If you look at this picture right here, guess what this picture looked like? It's a right triangle. So therefore, indicated in this picture, the length of p over the length of x is actually equal to, so notice that I can use any angle I want, but I want to use this angle because this is the angle that I actually know. How do I know this angle? I know vector x and vector u, the two vectors that form this angle. As long as I know the two vectors that form the angle, I wouldn't be able to figure out what the angle is. So therefore, I can say that length of p divided by length of x would be adjacent over hypotenuse. And guess what adjacent over hypotenuse is? It's cosine theta. And now here comes the interesting part. I can actually figure out what cosine theta is without knowing theta. How? Well, guess what? You learned in yesterday's video. cosine theta is formed by this formula right here. Provided we know the two vectors that form the angle theta, which we do. In this picture, clearly the angle is formed by vector x and vector u. So therefore, based on that, that would mean that cosine theta is also equal to vector x dot vector u over length of x, length of u. And since both of these theta are the same angle, therefore allow me to say that length of vector p over length of x must equal to x dot u over length of x, length of u. And here is interesting because then automatically I notice one thing. I notice that length of x cancel out from both sides, and length of u is just 1 because u is a unit vector. So that basically go away when I divide it by 1, and therefore tell me that the length of p must equal to the dot product between x and u. That's how long I need to make vector u to be to make it into vector x, vector p. So therefore, tell me the following. The component that's parallel or that in the direction of u is actually given by this formula. The components of x in the direction or sometimes parallel to u is basically given by this formula. Vector p is equal to x dot u multiplied by vector u. And x dot u become the length of vector p, and when I multiply vector u by the length of vector p, it becomes vector p because they have the same direction and now have the right length. And now come the next question is then how do I find the perpendicular component? Well, actually it's much easier now. The reason why, because now we know x, we know p. And since p plus q must equal to x right here, you see that equation right here? That would tell me that if I know p already, I can just move p to the other side and therefore allow me to solve for q. So therefore, once you find vector p, the component of x that is perpendicular to u is given by q equal to vector x minus vector p. You will be asked a question on components, so make sure you know these two formulas, otherwise you won't be able to do the problem. So now what I want to do is kind of give you one example, and I will leave you another example to do by yourself. And if you want to, we can go over the answer to the second example in class. So let's say here's a problem. Let's say given vector x to be equal to 2, 5. Once again, please don't get too hung up on the letter being used. Just try to make sure you read the question, understand the what vector represent. Because otherwise you keep on just paying attention to the letter being used in the formula and hoping that I use the same letter in the question that I'm going to ask you. You find out that you probably going to get confused because in some cases I will have to use different letters. So make sure you understand that. So here we have the vector x. And now I'm going to ask you to find the components of x. So therefore, x is the vector that we know, and we should try to break it down into two components. Components of x in the direction vector u equal to 1 over radical 2, 1 over radical 2. Now, this is probably very important right here. Whenever you're doing this type of question about components, you have to make sure that you pay attention to the following. Is that when you're given a direction, is this is this a unit vector? That is a question that you always have to ask. Because if you don't ask that question, you're going to mess up your math. You need the direction that you're given to be a unit vector. Because otherwise, it will mess up your math. Because otherwise, then when we do this process right here, this is not going to go away. Because it becomes some actual numbers. So we need that to be a length of 1. And because of that, you have to make sure that when the vector is given to you, it is a unit vector. What happens if it's not? Well, simple. You learn a process that allows you to turn a vector into a unit vector. You just do that. And if you don't remember what that is, look at yesterday's video. It's called normalization. So now I'm ready to form the two components. So what are the two components? Here we go. Let's say component P. Oops. Let's say component P. So use the formula. P would equal to x dot u multiplied by vector u. So therefore will be 2, 5 dot 1 over radical 2, 1 over radical 2. Then multiply by the vector 1 over radical 2, 1 over radical 2. So let's do a dot product right here. So the dot product will be 2 times 1 over radical 2 plus 5 times 1 over radical 2. So that is actually 7 over radical 2. Multiplied by 1 over radical 2, 1 over radical 2. So this is now a scalar multiplication. This here is a dot product. Once I do a dot product, I have a scalar, and now that scalar is multiplied to the vector. That's the reason why there's no dot between the dot product and the vector u. It's just a multiplication. Okay, and so when I do that, that equal to, oops, that just equal to 7 over 2, 7 over 2. And now with that in mind, I can now try to find Q. So what is Q equal to? Well, Q equal to vector x minus vector p. And since now I know I'm given vector x and I just found vector p, so I can now subtract them to figure it out. So that come out to be negative 3 over 2, 3 over 2. Now, I do want to kind of show you what is actually happening here. So show you in a picture. So let's see if I can insert a graph paper. Okay, there you go. Okay, I guess I can't really put it somewhere else. Alright, that's okay. I'm just going to write down 3 over 2 here and just get rid of this part right here. Okay, there you go. So I want to show you exactly kind of what happened here. So let's go ahead and try to draw my vector vector x. So vector is 2, 5. So therefore it will be this vector right here. So normally in physics, you'll probably break it down to the horizontal and vertical components. And so in this case, your horizontal component would be 2, and your vertical or 2, 2, 0. And then your vertical component is going to be 0, 5. Pretty simple. But that's for physics. We want a challenge. We want to do something different. So how are we going to do this? So what we want in this case, I want to define my two component using this vector, which is 1 over radical 2. So that's just basically the diagonal in this little square right here. Okay. Actually, you know what? Let me see if I can do this. Oops. Let's see if I can do this. No. Oh, yeah, I can do this. Can I do this too? Oh, yeah, I can. Okay. Okay. There you go, much bigger. Okay, so maybe easier for me to draw. So here's my vector 2, 5. Okay. You know what? Let me see if I can do this. I'm going to try to use this. Okay, my vector 2, 5. Okay, maybe that didn't look too good. Okay, maybe I just draw it. Okay. Let's see if I can just draw it again. So this vector 2, 5, that's vector x. And then the direction vector u is actually this vector that can go toward this corner. That will be my vector u. So now what did we do is we actually found two components of this based on this vector u. So what are the two components? The component p will go in the same direction as this thing. And we'll go to the vector 7 over 2, 7 over 2. So what is the vector 7 over 2, 7 over 2 going to be? Well, that would be just basically this vector. That kind of go all the way to 3.5. That would be my vector p. And then my vector q would go 3/2 back and also 3/2 up. So therefore it will be like this. Oops. It will be like this vector. This is my vector q. And there is the right angle. So that's what we find out. So in this type of question, when you find the two components, the two components that you're doing doesn't necessarily have to be horizontal or vertical. Not for us. We can actually define whatever direction that we want and then just form the two components of it. So in this case, I can actually look at this vector x along and compare that to kind of like this direction that's 45 degrees, and I can actually now find the perpendicular, which is q, and the parallel components. So the last thing I want to do is I'm just going to give you a question to work on, and then we can definitely go over that question in class if you guys want to. So I won't give the answer, and I'm just going to go over in class, or maybe I can ask some of you to find the answer. Find the component of the vector 3, 1, 1 in the direction of 4, 1, 0. Now notice that I did not label these two vectors for you, so I'm going to have to ask you to kind of read from the problem and try to understand which one is vector x, which one is vector u. So that way you can set up your problem. And I also want to point out to you is neither 311 or 410 are unit vector. So therefore guarantee that the direction vector that you want to use as u is not unit. So you're going to have to normalize that before you can do your math. So keep that in mind and give it a try. And ask me to go over it during class. Or I might ask you guys to, ask some of you to post your answers for vector p and vector q, and then we can all check and see if we all get it right. And if we all get it right, then I don't have to go over it. All right, and that would be the end of 1.4 dot products. So tomorrow we're going to start on the next video. We'll start on 1.5, which is Euclidean geometry. All right, talk to you guys soon. Bye bye.